In this section of the video, I'm going to be showing how to create a fluid model in WINPROP. So the first step is to open CMG Launcher and then click on WINPROP to open. So scroll to the bottom and then click on WINPROP to open. Okay. When you open WINPROP, the first thing you want to do is you want to save. So you go to File, Save, and I'm just going to name this, I'm going to save on my desktop and I'm going to name it Fluid Model. Save. And then under title, I'm going to name it Fluid Model as well. You want make sure your equation of state is set to Peng-Robinson 1978. Make sure your units are in field units and your feed is in moles. Next, you're going to go to the component selection tab. So on your left, you click on component select. Okay, so when we go to components, I'm going to go to viscosity. I'm going to click on viscosity on top. I'm going to change our viscosity model to Peterson corresponding state model and then apply changes. Okay. And then I'm going to click on component selection properties again. And I'm going to go back to components on top. And then we want to add all the components we have in our Excel data file. So if you go to your Excel file, you're going to see that you have a list of about 27 or 28 components. We're going to add all of these to our WINPROP fluid model. So the first thing we want to do is we want to add the components that WINPROP already has. So if you go to INS LIB, so this means insert from library, and then INS own is insert own. So this is where you go to insert any components that are not in the library. So I'm going to go to insert library, and then if you go back to your Excel file, you're going to see that we have CO2, nitrogen, and methane. So I'm going to add those first of all. So we had CO2, so to add CO2, I'm going to select CO2 and click on this arrow to choose CO2. We also had nitrogen, we had methane, and we had ethane. So I'm going to select 3 of them, and I'm going to move them to the right. Next we have propane, we have I-butane, N-butane, I and N-pentane. So I'm going to select those as well. So we had propane, we had I-butane, N-butane, I-pentane, and N-pentane. So I'm going to select all of those and I'm going to move them to the right. After those, we had C6 to C23. So I'm going to add C6 to C23. So select C6 and then all the way to C23 and move to the right. Now I'm going to click on OK, and all our components have been added except from C24 plus. Since this isn't just C24, it's C24 plus, I'm going to have to insert this manually. So back to WINPROP, I'm going to click on Insert Own. I'm going to name our component C24 plus. And then to define our own component, we need to enter at least two of the following three properties: molecular weight, specific gravity, and boiling point. Our table gives us specific gravity and molecular weight. So those are the two I'm going to use. Molecular weight is 550. I'm going to insert 550 into the table for molecular weight. 550. And our specific gravity is 0.92. So I'm going to go back to my table and insert 0.92. And I'm going to click on OK. I want to move this to the end of our list. So you select the row that it's on, and then you move it down with this arrow all the way to the bottom. Next, I'm going to click on Apply Changes. Apply Changes. Okay. The next step is to determine the composition of each component. On the left menu bar, I'm going to select Composition. And then now I'm just going to copy and paste compositions from the Excel file. So Control C and then paste. So now we've determined our components and we've determined the composition of each component. I'm going to save the file. The next step is to do a regression to match the experimental data that we have. So if you go to your Excel spreadsheet, there's a tab called Differential Libration Test. So basically this test has given us a couple of properties that were determined from an experiment. So we're going to use regression to match our model to these experimental results. So in WINPROP, I'm going to right click on composition. I'm going to select add after. I'm going to go to characterization. And then I'm going to select start regression. So again, it's right click on composition, add after, characterization, start regression. Under regression, I'm going to right click. I'm going to select add into regression block. I'm going to choose lab because it's a lab experiment that we have. Then I'm going to choose differential libration. So now we have a table that has similar parameters to what we have in our Excel table. I'm just going to copy and paste our pressures to the WINPROP table under pressure. And then I'm going to copy and paste all formation volume factor from our table. So that's this column. I'm going to paste over here. Next column is gas oil ratio. So back to our Excel table, gas oil ratio, copy, and then paste. The next column is specific gravity of oil. So back to our Excel, oil gravity, copy, and then I'm gonna paste. The next is gas Z factor. So that's gonna be this column. Once again, copy and paste in WINPROP. Gas formation volume factor. That's the same as BG. Same thing, copy, paste. gas specific gravity. Gas gravity. I'm going to copy and I'm going to paste as well. The next one is all viscosity. All viscosity. I'm going to copy and then paste. And then our final column is going to be gas viscosity. And then paste. And then we also want to include the specific gravity at standard conditions, which is given in our Word document. So oil gravity at standard conditions is 0.9164. I'm going to enter that value right here, 0.9164. All gravity at standard conditions. Next, you want to assign weights to each of the properties that we want to match. So since we have heavy oil, the most important properties to match are going to be viscosity and specific gravity. So I'm going to assign a weight of 3 to all specific gravity, and I'm going to assign a weight of 2 to viscosity. So basically, this just means that WINPROP is going to prioritize matching specific gravity first, followed by oil and gas viscosity. Actually, just oil viscosity. So I'm going to change gas viscosity back to 1. So it's going to prioritize matching specific gravity first, followed by oil viscosity, before it's going to try to match the rest of them. Next, you want to put in the reservoir temperature, which is 165. So on top where it says temperature, just put in 165, which is our reservoir temperature. Now the next thing that we want to do is, for regression to be done by WINPROP, we need to select what parameters WINPROP should change during the regression. So that is, what is WINPROP going to change in our fluid model to make it match our experiment. So if you click on regression parameters again, so you click on regression parameters, since from CO2 to C23 we're already in the WINPROP library, it makes sense to regress the parameters for C24 plus, because we defined this component by ourselves. So I'm just gonna click on each box by C24 plus. So that's basically telling WINPROP to change that it can change any of these properties for C24 plus. I'm gonna select the boxes for all the parameters. Next, I'm going to go to interaction coefficients. And in this case, I'm going to check all the boxes for C20 and above. For C20 and above. So basically, this is letting WINPROP know that it can change the interaction coefficient between C20 and CO2, C20 and nitrogen, C21 and CO2, and so on and so forth. Next, I'm going to go to the viscosity parameters tab on top. And then in this case, I'm going to say that WINPROP can change any of these values. I'm just going to select all the boxes for all the parameters under viscosity. Next, I'm going to go to regression controls. So I'm going to go to the regression controls tab. And this basically sets how good of a match you want WINPROP to produce. So let's just say we want our tolerance to be, convergence tolerance to be 1e minus 20. So that's high accuracy. I'm going to say the maximum number of iterations that we would like is 2000. And then I'm going to say the number of simultaneous regression parameters to change is 20. And then you can save. Next, we want to create a two-phase envelope to enable us to determine the bubble point of our reservoir fluid. So you go to regression parameters and right click on add after, click on calculations, and then select two-phase envelope. So regression parameters, add after, calculations, and then two-phase envelope. So you select that, and then you can leave everything as is. Next, we're gonna, in order for us to be able to export our fluid model to other CMG applications, we're gonna have to create an output file that is compatible with other CMG programs. So to do that, we're gonna right click on two-phase envelope, click on add after, click on simulator PVT, and then click on black or PVT data. So basically this is gonna create a fluid model that can be exported into any CMG black oil simulator. I'm going to click on black oil PVT data, and then in the tab that comes up, I'm going to leave everything as is except from under calculation of all properties above saturation pressure. I'm going to check the third box which says user extrapolates to a certain order. I'm gonna extrapolate to order 3. So basically, above the bubble point, WINPROP is just gonna extrapolate from points below the bubble point, and the extrapolation is gonna be done to the order of 3. So click on the third box and make extrapolation order 3. Next, we're going to go to the saturation pressure tab on top. So click on saturation pressure on top, and then under temperature, I'm going to enter 165. Under saturation pressure estimate, I'm going to enter 1550, which is what we were given. And then I'm going to check the improve saturation pressure estimate tab, and then under pressure levels, so basically this is where you determine what pressure, at what pressure your output is going to be. So at what pressure do you want CMG to give you formation volume factors for? Click on tools, click on insert row. The first pressure we want is standard pressure, so that's 14.5. The next one is 500, and then we're just going to go all the way to 6,000 by increments of 500. And the reason why we're going to go up to 6,000 is because that's the maximum pressure we ever expect to see in the reservoir, because the maximum injection pressure is set to about 5,500 psi. So we don't expect to ever see pressures above close to 6,000. So I'm just gonna insert rows all the way to 6,000. Click on Tools, Insert Row. You just enter values. Tools, Insert Row, 4,500, 5,000, 5,500, and then finally 6,000. Next, we're going to go to the Water Properties tab. So you click on Water Properties, and then under Reference Pressure, I'm going to enter our reservoir pressure, which is 4,700 psi. Under Formation Volume Factor at Reference Pressure, I'm going to enter the water formation volume factor, which is 1.0245. 1.0245. Under water compressibility, I'm going to enter 3.187 e to the negative 6. So that's 3. I don't think I copied correctly, so I'm going to go back to I'm going to paste again. I'm just going to enter manually, so 3.184 e to the negative 6. And then the viscosity at reference pressure is 1 centipoise. And our water density is 62.4. So back to WINPROP, this is 1 for viscosity of water, and our density is 62.4. So now I'm going to save. I'm going to go to all properties. I'm not going to change anything. The same for gas. I'm going to leave everything as is. I'm going to save this again, and then I'm going to run. So now if you go to desktop, if you go to our desktop, you can see that WINPROP has created a couple of files from our fluid model file. So we have fluid model.imx, a fluid model OUT file, and a couple of other fluid model files. Fluid model.imx is the file that we are gonna import into CMG IMEX builder when we start developing our reservoir. Yeah, but back to WINPROP, we can look at some plots like our PT plot, and then using this curve, for example, if you go all the way up from about 165, that's like around here, you can determine the exact bubble point of the reservoir. And yeah, that's it.